Hi friends, welcome to my channel. I hope everyone is doing good and you are watching our latestly posted videos. We are posting lots of good videos for you in recently, so make sure you watch the playlist. Today we are going to solve Leetcode problem 3349 adjacent increasing sub-arrays detection 1. So another array related interesting coding problem. So we are going to go through this problem, understand the logic as well with some examples so that it will be easy and clear for you. So let's start with the problem statement first. Given an array nums of n integers and an integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Okay, both should be strictly increasing. Specifically, check if there are two subarrays starting at indices a and b. A is less than b, where both subarrays from nums which is from a to a plus k minus 1. So I'll explain you what they are saying are strictly increasing. So both should be adjacent subarrays, okay, of length k, and the subarrays must be adjacent, meaning that b is equal to a plus k. Return true if it's possible to find two such subarrays, otherwise return false. So nums dot length is between 2 to 100, so maximum 100 numbers will be given to us in that list of nums, and 1 is less than 2 into k is less than equal to nums dot length, and numbers will be between minus 1000 to plus 1000. So let's understand this problem better with some examples, then it will be more clear for you, right? So what they are saying is we have to find out in this first example, right? First example, we want to find out in this array adjacent two subarrays with a length k which are strictly increasing, right? Strictly increasing. So for example, if you take a look at this subarray, this is what length 3, right? And it is a strictly increasing subarray. There is an adjacent subarray here 2 3 4. This is also strictly increasing and they are adjacent to each other, right? So if we find such subarray, then we want to return true in this case, right? So that's what they want us to find out, if there is such subarrays, right? This is another case basically, which is a negative test case. So here k is equal to 5. It means that we want to find out length 5 subarray which are strictly increasing. Is there any length 5 subarray? No, right? This one is not a strictly increasing because after 4 you are getting 4. So this cannot be a strictly increasing basically. There is no subarray here with length 5 which is strictly increasing, okay? And obviously if there won't be any adjacent subarrays as well, right? So in this case you will return false, right? So strictly increasing means the number should be greater than the previous number, then it will be strictly increasing. So I hope you understood this problem clearly, what they are asking. It's pretty straightforward to understand. So can we take this subarray 5 7 8 and 9 to 3? So we cannot, right? Because this one 9 to 3 is not a strictly increasing subarray in this case, right? So it means that we want to find out uh, for so let's say you find out this is one subarray which is strictly increasing, right? Now what you want to find out, you want to find out adjacent subarray which should be also strictly increasing. So you will check next k elements, right? This is k is 3 in this case. So is this strictly increasing? No. So you cannot take these subarrays basically, right? So you have to basically keep checking for each possibility, right, until you find out one like two such subarrays which are adjacent and strictly increasing. So what we will have to do in this case is first we will understand this logic, so it will be clear for you. You will keep chunks, basically chunks of arrays. What is the length of the chunks? The chunks will be 6 length, k multiplied by 2, right? 6. Why we are taking 2? Why we are taking 6? Because we want to find adjacent subarrays, right? So one subarray will be length 3 and the next will be also length 3. So total length will be 6. For example, I will take these 6 elements in the beginning, right? These 6 elements I will take. You understood this, right? Why we are taking 6? I already explained you, because the length is k. So the adjacent subarray's length will be 6, k by 2, right? K multiplied by 2. So here we will find out this one is strictly increasing. Yes, it's strictly increasing. Now you want to find out if next should also be strictly increasing, so you have to check this one. So this is not strictly increasing, right? After 9 you are getting 2, so we cannot take this one, right? So now you will take the next chunk. So what will be your next chunk? So next chunk will be this one, right? This is your next chunk, right? These are again 6 numbers, correct? So now again you will check 5 7 8 strictly increasing, yes. Then you will check 9 to 3 strictly increasing, no, right? So it's also not possible here. So you will keep going next. Now again next 6, right? You are from here to here, so next 6 you are checking now again, right? Now first 3 you will check. So this is one subarray. Is it strictly increasing? Yes, this is a strictly increasing. So it means that since this is strictly increasing, we are interested to check this, right? Because if this is not strictly increasing, then there is no point to check the adjacent, right? You understood, right? This must be strictly increasing, then only we will check the next one, right? So next one is this. Is this strictly increasing? Yes. So it means that you found out 2 sub arrays which are next to each other and both are strictly increasing, then you will return true. So this is how we can approach this problem, right? So now you understood this logic, I hope. So you will keep chunks, basically chunks of that array, k multiplied by 2, and then you have to uh, keep looking of whether they are increasing, adjacent and increasing, basically, right? Increasing. Then only you, if both you find like that, then only you will return true, otherwise you have to return false. So this is a case where you will never find it, so you have to return false, basically, right? So this is what the problem statement is, and this is the logic how we can solve this problem. So you understood it clearly. So the best way to implement this one in Java is using two pointers approach, right? So we'll take 2 pointers, and as I explained you, always we will keep a chunk of array which is k multiplied by 2, and we'll keep looking for those sub arrays, right? So in this case k is 3, so you will take 6, always 6, basically, right? You wanted to take a look of this 6 uh, kind of array, right? So let's take a look at Java. I'll explain you better more here. So has increasing subarrays is what we are implementing. Nums, which is list of numbers, is given to us. K is given to us as input. This method returns boolean, which is true or false. So as I explained you, so we'll take one size. Size is what? Nums dot size minus 2 multiplied by k. Why 2 multiplied by k? I already explained you, because we are taking a chunk of that array which is 2 multiplied by k. That's why we should only go until that point, right? So you should, in this for loop, you will go from 0, but you will only go until I is less than equal to this size, because we are taking chunk of that 2 multiplied by k, correct? I explained you that just now. And I plus plus, so you will so in this first one you wanted to check whether you are finding the first sub array which is strictly increasing, right? So j is equal to I plus 1, end is equal to I plus k. In this while loop you will keep checking if the numbers are in a strictly increasing order, right? Nums of get j minus 1 should be less than nums of get of j, right? And you keep incrementing the j pointer. Here you will check if j is less than end, it means that your array is not strictly increasing, then you will just continue in the for loop. This is important. Your first sub array that you are looking at, if it is not strictly increasing, you don't want to check for the second one, correct? So you will continue in the for loop. Okay, so this is the first sub array we are checking if it is strictly increasing. Let's say it is strictly increasing, then you will come here, you will increment your j, and your end value should be end plus k value, right? It means that your first sub array you found now, basically when you are reaching here, it means that you found your first sub array strictly increasing. Now what you want to check for the second one now, right? The second sub array of length k you want to check if it is strictly increasing, right? Okay, so that's what we are doing here. So while j is less than n and nums of gate j minus 1 is less than nums of gate of j, it means that they are strictly increasing. We are checking and incrementing our j pointer here in this while loop. Okay, after that you will reach here, right? And at the time you will check if this j is equal to n, it means that you found the second sub array also strictly increasing. If it happens, you will return true, basically, correct? So exactly what I explained you, right? Otherwise you will continue in this for loop with the next index, basically, correct? Okay, at the end, if you never find any such two subarrays, then you will return false. So this is the way you can solve this problem. So we will now run this code and make sure the code gives us correct answers. And our code is working correctly with the test cases. As you can see, we are getting correct answers. For first one true and for second one false. Submit this code to the Leetcode to make sure this is getting accepted. And the code got accepted on 100% on the Leetcode, which is pretty good. So it's Leetcode 3349 adjacent increasing subarrays detection 1. Another interesting array coding problem that I hope you understood the logic and how we have used these chunks of arrays to detect if adjacent increasing subarrays are there basically. And if this whiteboarding session and example helped you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription really helps and supports this channel. It takes a lots of efforts to create these videos, so be generous, and if you like these videos, then give it a like and share this with all your friends and colleagues. On this channel, you will find more than 500 different varieties of coding problems explained with lots of examples. All important coding questions varieties are covered for you on this channel. That includes graph, matrices, binary search trees, binary trees, problems related to different data structures such as uh, arrays, strings, uh, then priority queue, min heap, max heap, hash set, hash map, problems related to strings. So everything is here, dynamic programming, recursion, BFS, DFS, all these important varieties which typically gets asked in coding as well as in-person rounds of interviews are discussed in details with examples. So don't forget to check the playlist. They will definitely help you out in your interviews. Keep learning, keep coding, keep solving more varieties of coding problems, and thanks for watching this video and have a great day ahead.